They should be here by now. That's the thing that gets me. If even one civilization in our galaxy got a 1 billion-year head start on us, just one, and if they expanded at even a fraction of the speed we can imagine, they should have reached every corner of the Milky Way long before humans ever existed. They should have passed through our solar system, left something behind, done something we could detect. And they didn't. Or if they did, we found nothing. And that silence, that complete, unbroken, maddening silence, is either the biggest mystery in science or the biggest clue. I think it's a clue. And I think the physics has been trying to explain it to us all along. Let me take you through the reasoning, step by step, with real numbers and honest logic. Because the answer to this question is not hiding behind philosophy or wishful thinking. It's hiding behind arithmetic. And once you see the arithmetic clearly, the silence stops being mysterious and starts making complete sense. Let's start with what we know. The Milky Way galaxy is about 13.6 billion years old. That's almost as old as the universe itself. Stars have been forming in it for nearly that entire time. And around many of those stars, planets have been forming too. Rocky planets, planets in the habitable zone, planets where liquid water can exist and where chemistry can get complex enough to produce life. We know this not from guessing. We know it from observation. In the last 30 years, astronomers have discovered thousands of exoplanets, planets orbiting other stars. And the data suggests that planets are not rare. They're common. Most stars have them. Many have rocky planets in their habitable zones. The ingredients for life are scattered across the galaxy like seeds scattered across a field. Now, life on Earth arose about 3.8 billion years ago. The universe gave Earth about 9 billion years to exist before life showed up here. That means other planets, orbiting older stars, had a head start. Stars formed earlier in the galaxy's history. Planets around those stars had more time to develop. If life appears anywhere close to as readily as it appeared on Earth, then there are planets in this galaxy where life got started not millions, but billions of years before it appeared here. And if life can become intelligent, as it did here, and if intelligence can develop technology, as it did here, then there are civilizations out there that may be not thousands, but billions of years ahead of us. Civilizations that have had more time to develop than the gap between when the first fish crawled onto land and right now. A civilization 1 billion years more advanced than us. Think about what that means. We went from stone tools to landing on the moon in about 12,000 years. In 1 billion years, even at a pace 1,000 times slower than ours, a civilization would have achieved things we literally cannot imagine. Their technology would be indistinguishable from magic to us. They would have had time to reshape star systems, harvest the energy of stars, and potentially spread across vast stretches of the galaxy. And yet, silence. No evidence. Nothing we can confirm. This is what Enrico Fermi noticed. Sitting at lunch in 1950, he looked at the numbers and asked the simplest question imaginable. If the galaxy is this old, and if intelligent life can arise in it, where is everyone? It became known as the Fermi paradox, and it has haunted astronomy ever since. Now, I want to give you the explanation that I think is most honest. Not the most dramatic, not the most philosophical, the most physically honest. The explanation starts with the speed of light. You've probably heard that nothing can travel faster than light. But I want you to understand why that matters here. Not just as a factoid, but as a fundamental constraint that reshapes everything about how civilizations can interact. Light travels at 186,000 miles per second. In a year, it covers about 5.88 trillion miles. Our galaxy is 100,000 light years across. That means even a signal, not a ship, just a radio wave or a laser pulse, takes 100,000 years to cross the galaxy. And a physical object, which must travel slower than light, takes longer still. Now think about what that means for a civilization trying to expand. Let's say they develop interstellar travel and start moving outward from their home star system. They go to the nearest star. It takes decades or centuries. They build a colony. The colony grows. Eventually, it sends ships to the next star, and so on. Hop by hop, generation by generation, the civilization spreads outward. How fast can this expansion happen? At best, at genuinely optimistic best, maybe 1 to 10% of the speed of light for the ships themselves. That means the wave of colonization moves outward at somewhere between 1 and 10 light years per century. Probably slower, because you stop at each system and spend time there before moving on. Even at 1% of light speed, a civilization that started expanding 1 billion years ago would have spread outward by 10 million light years. The galaxy is only 100,000 light years across, so they should have covered the whole galaxy hundreds of times over. This is exactly why Fermi's question is so sharp. By the numbers, an ancient expanding civilization should be everywhere. And they're not. So what's the explanation? There are many proposed answers. Let me walk through the ones that get serious attention. And then I'll tell you which one I find most compelling, and why the physics is the key to everything. The first explanation is that intelligent life is extraordinarily rare. Maybe the chain of events that produced intelligence on Earth, the right star, the right planet, the right chemistry, the right evolutionary pressures, at exactly the right time, is so unlikely that it has only happened once in the entire galaxy. Maybe we are genuinely, profoundly alone. Not because the universe doesn't have the ingredients, but because the recipe works almost never. This is called the rare earth hypothesis, and it's taken seriously by real scientists. But I find it a little unsatisfying, because it's very rare is not a physical explanation. It's just saying the number is small, without explaining why the number is small. The second explanation is that civilizations destroy themselves. They develop technology. They discover weapons capable of ending their civilization. Nuclear bombs, engineered pandemics, runaway artificial intelligence, climate collapse. And before they ever develop interstellar travel, they wipe themselves out. The universe is full of civilizations that almost made it, but didn't. This is a darker answer, but a physically plausible one. We know from our own experience how close a technological civilization can come to self-destruction. The Cold War brought us frighteningly close to nuclear annihilation multiple times. So the idea that most civilizations don't survive their own technology is not ridiculous. It's sobering. But it still doesn't fully explain the silence. Because even if 99.9% of civilizations destroy themselves, the remaining 0.1% that survive, especially the ones that got a billion-year head start, should still be detectable, should still have expanded, should still have left a mark on the galaxy that we'd notice. The third explanation, and this is the one I find most physically honest, is that expansion is much, much harder than we assume. And the reason it's harder is something we've already talked about in different ways. Distance, energy, time. The physical cost of interstellar travel is so extreme that even a highly advanced civilization may never expand beyond a small bubble around their home star. Think about it this way. Every time a civilization tries to send a ship to another star, they pay an enormous energy price. We've calculated that accelerating even a modest crude ship to 10% of the speed of light requires more energy than most countries produce in a year. Just for one ship, one trip. That cost never goes away. Physics doesn't give discounts. And a civilization spreading across hundreds of billions of star systems would have to pay that price hundreds of billions of times. At some point, the economics of expansion break down. The energy cost of sending ships and maintaining communication across vast distances exceeds the benefit of having colonies far away, especially when those colonies, separated by thousands of light years, evolve independently over millions of years and stop being part of the original civilization in any meaningful sense. A galactic empire doesn't work. Not because the technology isn't good enough, but because the physics of distance destroys communication, coherence, and motivation across the required timescales. You can't run an empire when orders take 50,000 years to travel between the capital and the frontier. You can't maintain cultural continuity when your colonies have been evolving in isolation for millions of years. You can't sustain the motivation for expansion when the return on investment is measured in geological time. So what actually happens to civilizations? I think most of them do what any sensible entity does when it fully understands its physical constraints. They optimize for what's actually achievable. They build rich, deep, complex civilizations in the space they can realistically occupy. Their star system, maybe a handful of nearby stars. They study the universe with extraordinary instruments. They develop their science, their art, their mathematics, their understanding of physical reality to depths we can't currently imagine. And they don't expand wildly across the galaxy because the physics makes it not worth doing. This would explain the silence, not because civilizations don't exist, but because advanced civilizations that understand physics don't become galaxy-spanning empires. They become incredibly deep, incredibly wise, incredibly self-sufficient civilizations contained within a small region of space, and invisible to anyone far away because they're not doing anything detectable at interstellar distances. A civilization living quietly in its own solar system, not broadcasting loudly, not building megastructures across multiple star systems, not sending fleets of colonization ships, that civilization would be effectively invisible to us. We would have no way of knowing it exists, even if it was only a few hundred light years away. And here's a detail that doesn't get enough attention. We've only been seriously looking for about 60 years. We've been running SETI programs, the search for extraterrestrial intelligence, since the 1960s. 60 years out of the 13.6 billion years the galaxy has existed. We've listened to a tiny fraction of the sky, in a narrow range of frequencies, for less than a blink of cosmic time. And from that tiny brief search, we conclude, cautiously, that we haven't found a confirmed signal yet. That's not the same as saying no signal exists. We've barely looked. A scientist who searches 1 square meter of the Sahara Desert and finds no water doesn't get to conclude the desert has no water. The search has to match the scale of the problem before the absence of results means anything. Our search is not yet at the scale of the problem. Not remotely close. And there's another dimension to the silence that I think is worth sitting with. The signals we do send and receive travel at light speed. Any civilization more than a few hundred light years away has not yet received our radio broadcasts, the ones we've been sending for about 120 years. And any signal they sent 120 years ago from more than 120 light years away hasn't reached us yet. We are in the very early moments of our ability to make ourselves known to the galaxy. We've barely cleared our own cosmic throat. So the silence we hear might simply be the silence of a universe where everyone is far away, communication is slow, and we haven't been listening or broadcasting long enough to have heard anything or been heard by anyone yet. Not a silence of emptiness, a silence of patience and distance. Now I want to address one more explanation that I think is interesting, even if I'm skeptical of it. The zoo hypothesis. The idea that advanced civilizations know we're here and are deliberately staying quiet, watching us, not interfering, the way a scientist watches an experiment without disrupting it. It's a creative idea, and it's impossible to rule out entirely. But I find it hard to believe that every single civilization in the galaxy would agree to maintain this silence. It only takes one rebel, One curious young civilization that decides to say hello, to break the agreement and make contact. And yet nothing. That level of coordination across hundreds of millions of years and billions of star systems strains credibility. The simpler explanation, the one that requires no coordination, no conspiracy, no deliberate behavior from anyone, is physics. Distance does the silencing automatically. No agreement required, no deliberate choice, just the cold, hard, neutral enforcement of the speed of light and the scale of space. And I love simple explanations, not because they're always right, but because they should always be tested first. And the physics explanation here is very simple. The universe is large. Travel is hard. Communication is slow. Civilizations are local. And from where we sit, with our 60 years of searching and our 120 light-year broadcast radius, we have not yet seen enough to conclude very much at all. What I believe, what the physics strongly suggests, is that the galaxy contains life. Probably a lot of it. But that life is spread across an enormous, ancient, mostly silent volume of space where the distances between civilizations are so vast that they are effectively islands. Each one brilliant, each one curious, each one looking outward at the same stars, each one getting back the same answer. Silence. Not because no one is there, but because the universe is so large and signals travel so slowly and physical travel is so hard that the silence is the natural, expected, physically inevitable result of the way the cosmos is built. The clue wasn't hidden after all. It was always right there in the numbers, in the distance, in the speed of light, in the energy required to cross the void. The physics was explaining it to us all along. We just needed to listen carefully enough to hear it. And maybe that is the real lesson here. The universe rewards careful listeners. It rewards patience. It rewards the kind of mind that takes the numbers seriously and follows them wherever they lead, even if they lead somewhere quieter and stranger than we hoped. I have always found that kind of honesty more exciting than any comfortable answer. Because an honest answer, even a hard one, is worth infinitely more than a beautiful story that doesn't hold up. The silence makes sense, and understanding why it makes sense is one of the most extraordinary things a human mind can do.